Earth's changing surface. Weathering. Imagine standing on a tall mountain. In the distance, you might see a river or an ocean or even maybe a large forest. Now imagine it's 1,000 years from now. Will this mountain still be here? Will you still be able to see the landforms? What did this area look like 1,000 years ago in the past? Landforms on Earth are constantly changing, but the changes often happen so slowly that you do not notice them. So what causes these changes? Well, there is a combination of constructive and deconstructive processes that produce landforms. Constructive processes build up features on Earth's surface. For example, lava erupting from a volcano hardens and forms new land on the area where the lava falls. Destructive processes tear down features on Earth's surfaces. Quick processes include something like a hurricane, which may reshape a coast or a shoreline, but some processes are longer. Constructive and destructive processes continually shape and reshape the surface. One type of destructive process that changes Earth over a long period of time is weathering. And weathering is the process that breaks down rock and other substances at our surface. Heat, cold, water, and ice all contribute to weathering. Repeated freezing and thawing, for example, can crack rock apart into smaller pieces. Rain can eventually dissolve minerals that hold rocks together. When forces of weathering break rocks into smaller and smaller pieces, a force called erosion carries those pieces away. Erosion is the removal of rock particles by wind, water, ice, or gravity. Weathering and erosion work together continuously to wear down and carry away rocks or surface. There are two kinds of weathering, mechanical weathering and chemical weathering. Both types of weathering act slowly, but over time they can even break down the largest and hardest of rocks. When rock is physically broken into smaller pieces, this is called mechanical weathering. If you have seen rocks that are cracked or split into layers, then you are watching mechanical weathering taking place. When water, oxygen, carbon dioxide, living organisms, or even acid rain break down rock through the process of chemical changes, this is called chemical weathering. Chemical weathering can produce new minerals as it breaks down rocks. For example, granite is made up of several minerals, including feldspar and quartz. But eventually, through chemical weathering, granite eventually changes the feldspar minerals into clay. Chemical and mechanical weathering often work together. As mechanical weathering breaks rocks into smaller pieces, more surface area becomes exposed, therefore chemical weathering takes place. Now, the causes of mechanical weathering include freezing and thawing, plant growth, the actions of animals, and abrasion. Now, abrasion refers to the grinding away of rock by other rock particles that have been carried by water, ice, wind, and gravity. In climates that have cooler seasons, one of the biggest forces of mechanical weathering is freezing and thawing of water. When water freezes in a crack of a rock, it expands and makes that crack bigger. This process is called ice wedging, and it will widen cracks. And you have seen this maybe in sidewalks or potholes in the streets. Animals also cause mechanical weathering, especially those that burrow into the ground. These include moles, gophers, prairie dogs, and even some insects. As they burrow into the ground, they loosen apart the rocks that are in the soil. Plants, also when their roots grow, these roots can enter cracks in rocks. And as the roots grow, they force the cracks further apart, and over time, the roots can pry apart cracked rocks. This might happen if you've ever seen trees get removed from around homes because those roots are starting to break into the rocks that are part of the foundation of a home. When talking about the causes of chemical weathering, the most important cause of chemical weathering is water. Water weathers down rock by dissolving it. When a rock or other substance dissolves in the water, it mixes and forms a solution. Over time, many rocks will dissolve in water. Over the past hundreds of years, industries have boomed, and these industries run on coal, oil, and gas for energy. Burning these fuels have polluted the air with sulfur, carbon, and nitrogen compounds. And these compounds react with water vapor in the air, forming acid rain. Acid rain causes very rapid chemical weathering. Oh, carbon dioxide is another gas found in the air. This causes chemical weathering as well. It dissolves rainwater, and then that water sinks through pockets in the soil. What is the combination of carbon dioxide and rainwater is a weak acid called carbonic acid. And this easily weathers rocks such as marble and limestone. Many buildings that have stone structures, such as the Notre Dame in Paris, have weathered statues, both from acid rain and carbonic acid. Now, plants have roots that contribute to mechanical weathering, but they also produce weak acids that slowly dissolve rock around the roots. Plant-like organisms, also such as lichen, grow on rocks and produce weak acids that chemically weather away the rock over time. And another important cause of chemical weathering is oxygen, which is a gas in the air. When oxygen combines with iron in the presence of water, a process called oxidation occurs. And this product of oxidation is rust. So rock that contains iron will also oxidize or rust. And the rust makes rock soft and crumbly and will give it a reddish or brown color. There are two important factors that determine the rate at which weathering occurs. These factors include the climate the rocks are in and what the types of rocks that they are. When talking about climate, you need to look at average weather conditions, the amount of rain, and temperature. Both chemical and mechanical weathering occur faster in wet climates because rainfall provides water needed for chemical changes, as well as for the freezing and the thawing that we talked about with mechanical weathering. Higher temperatures also cause chemical reactions to occur faster. So all these weathering will happen faster if it's a hot and wet climate. Now, minerals that make up rock also determine how fast it weathers. Those made of minerals that do not dissolve easily in water, of course, will weather more slowly than those rocks made of minerals that do dissolve easily in water. There are some rocks which are permeable, meaning that they are full of tiny little air spaces that allow water to seep in. Permeable rocks, of course, will weather chemically at a faster rate because the water can now get into those little tiny pockets and dissolve and remove material faster. Let's take a break here, and it's time to show what you know.